Hi there, welcome. In this video we're going to go over a software tool called Logisim. That's the tool I'm going to use in order to build up the CPU. It's a freeware piece of software. I've put a link below where you can go and download it. Okay, so let's get started. You can pick up the gates. Here you can see up at the top left hand corner there's 3 gates sitting there, but you can also get into the pull down menu here under gates and you can see there's a list of gates there. So let's just pick a gate and get started. So let's pick the AND gate, and I think we'll make it a smaller size. So I've made it narrow, it just makes it smaller, and we're only interested in having, say, 2 inputs, so you can change the number of inputs there to 2, and you can see that we have 2 inputs there in blue, an output there in red. When we hover over the top of them, you see the little green circle. So you want to draw a line, you hover over the top, left click, and you can draw the line. So there we go, there's 2 inputs and 1 output. You also got to put down pins, so there's an input pin there. You can also get the pin from the wiring section here. So there's a pin there. When we put the pin down, you can see the little green dot there. That's where the connection is to the pin. And we can change the direction of the pins by just changing this direction here. So you can make it face, say, west. So now the connection's at that point there, and we can change it to north and south as well. So let's go put that back to east, and we'll make the connection. So we'll take the pin and place it on the wire, so they can see the connection's been made, and you can see the wire changes to that dark green. So the dark green represents a 0. Okay, so we'll go up and grab another pin, bring it down, and we'll just stick it there. And you can give the pins labels, so I could label that one A. And again, you can change the label direction there to north, south, east and west, and I'll call that pin B. Okay, and now this is the output pin here. Okay, so you can click on that for output. The output pin is circular, and I can place it there, and the output there is connected up. Okay, so now if you want to run through the simulation, you click the little finger on the top left hand corner. That's us in simulation mode. So when I change this to a 1, the colour for a 1 is a bright green, okay, but the output's still 0 because it's an AND gate. So I'll put that back to 0 and make that a 1, and of course the output's still 0, and the output will only be 1 whenever both those go high. So if I make that high, when I make that high, that'll change to a 1 and that'll go green. Okay, so there you go, there's your output, and that's your simulation done. So the next thing we want to do is build hierarchies. So let's take this and we'll produce an AND gate from it. Okay, so I've come out of the simulation mode, just into normal mode, and let's take that out and we'll stick in an inverter, a NOT gate. So stick that in there, there to there. Okay, and that's us redone created an AND gate from this. Okay, so if we're wanting to create a hierarchy, you'll notice at the moment this little circle thing here, we're sitting on a page called main. Main is really just your rough copy. It's where you put your circuits together and test them. Now if we wanted to create an actual instance for this, here we could go to project, add circuit, and we could call it CPU underscore NAND. Okay, so now we've created another instance here, another page called CPU underscore NAND. There's nothing in it, but we can get into main and we can go our control X or copy if you want to retain it, the value, the picture there as well. So we'll cut it, get into the CPU NAND, and we'll go control V. Okay, so now we've got a NAND gate sitting in our CPU NAND, and if we wanted to draw the hierarchy, we can right click on the CPU NAND and we can get into edit circuit appearance. Okay, so that gives you a little circuit there. Okay, so we could redraw that. So let's just, you could draw it out as an AND gate using the shapes in here, and it's not bad, it's quite usable, but let's just, for simplicity at the moment, just draw it as a bigger block. Okay, so I could draw the block there. I can change the border width to 2. I can pick this little point up. I'll explain that later. I don't know about that just now. Now this point here, I'll drag that over as well. Again, we'll explain that later, we don't need to know about it at the moment. Now that there is your output. Now you can't quite see it because it's off the corner of this page, but well, I'll click on the input, you can just about see that there. So when I click on that input there, you see it in the bottom right hand corner. See the bottom right hand corner it appearing as your input there. Okay, it actually disappears as I move off, so okay, but you can see that's one of the inputs, so that allows you to tell what pin you're actually focused on. So we take that input there and we can shift it. Okay, just select it, move it over, and we can take the other input there, we can select that, move it over, and we can take our output there, I'll select it and move it over. Okay, and we can delete that off, it's not needed, and we can also give these names. So if you go to the A there, you can put in names, so you could call this A, B, O for output, and you could call it NAND for NAND. Okay, so you can grab these and drag them over. So that's our A input, that's our B input, that's our output, and we've called our little gate a NAND gate. Okay, so now that there instance is available for you to mess about with in the main section. So if I went back to main, okay, now there's nothing in it, okay, because we cut the circuit out and pasted it into NAND. But I can go to NAND, CPU NAND, and I can pull across the gate that we just created. So there's a gate we just created, and again it's got two inputs and it's got one output. So again, we can keep building up these hierarchies. So I can, if I click on it and go Control D, it copies it. We can take that copy and put it there, and I do say Control D again, copy that and paste it there. Now we've got 8 inputs and 4 outputs, so let's take the outputs. Okay, now I'm not actually building up anything particular here, it's just some random structure just to show you how this works. So let's say we put that through an OR gate, and we want the OR gate to be 4 inputs. Okay, so there's a 4 input, and we connect the inputs, output of these two inputs here. Now you've got to be careful as well, because I could take this connection here, and you'll notice there's not any blue connection in the middle of it. I could take that along there and sit it there, and I might think it's connected, but it isn't. Okay, so you have to be very careful with that. Okay, so let's take that back and we'll actually connect it up. There we go. So that's our outputs connected, and we'll just give that an output, and again we'll have a pin there, and we'll place the pin down, and we'll just call that again O for output. Okay, now we're going to have 8 inputs here. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we could create a hierarchy with 8 inputs if we wanted to, but a useful thing to do is be able to create a bus so that these all just go to one input. So we can do that there within the wiring section. There's a thing called the splitter. So we put the splitter down, and we'll put the number of fan outs to 8, and the bits are 8. Okay, so it's 8 bits going to come into this, and again you can turn this round to be north, south, east or west, so, but we'll just leave it as is at the moment. Also note that you can see it's got 0 to 7. Okay, you can change that round about so the top one is 7 and the bottom one 0 if you want, but obviously you have to be very careful with that when it comes to hierarchies, that you don't mix these up via the hierarchies, otherwise you end up with short circuits. Okay, so let's connect this up, so that can just go ahead in here. 1, 2, 3, 4, just bear with me to put these in. Okay, and that's the very last one done. Okay, now we could go and get an input pin, so there's a pin there, and we want to connect it up here. Okay, if when I connect this pin on here, we'll get an error when I do it. There's an error, incompatible widths. It's telling me that that's an 8-bit connection, and that pin there is only a 1-bit pin, so we need to change that to 8 bits. And then we've got our circuit all completed. Okay, I'll shift that over there so you can see it a bit better. Okay, and we can give that pin a label. We'll just call that I for in, and let's say we put that at north. Okay, so there's your input, that's your output, and again it's been created on this scrap page called main, and we can then create a new hierarchy. So we'll add circuit, and we can call that CPU underscore, well, we'll just call it G1. Okay, CPU underscore G1, there it is there. And again we can get into main and we can select everything, just left mouse, hold it down, and it selects everything. We can control X and we can stick it in, control V. Okay, and then we can get into this CPU gate and we can create the hierarchy. We can call that edit circuit appearance, and again this thing here has just got an input and an output. So, but this input here is an 8-bit input, and output there is just a 1-bit output. So again we'll just redraw something there just to make it a bit bigger. Okay, we can take this one here, take it over. You can see that it places that's the output one there, and that's the input there. And we can take this connection here, pop it up, and again we can give it names. We can call it A, B, well not a B in here actually, so we call A, O, and we can just call it G1. Okay, and we don't need that. Right, so that becomes A, and output and G1. In fact, there's not even A. We'll call it I for input, because that's how it's defined in the lower hierarchy. Okay, so this has created another instance, so it means that we can go back to CPU NAND and we can pick up a NAND gate which we created, and we can pick up this new gate which we created. We can maybe take say a couple of these, control D. Okay, and then you can connect these, say up to this thing here. Okay, and then take an output there, and then have your input there, and again you can put your pins on these, and you can create another level of hierarchy, and we can keep building up these levels of hierarchy. That's all I really want to say in this video. That's pretty much 90% of everything we need to know about Logisim. All the rest of it will pick up as you go along and you see the simulations whenever I gradually build up the CPU. Just to show you quickly, there's the wiring section. So you've got input pins, you've got a tunnel. The tunnels are a useful one. I'll just show you the tunnel quickly. If I pick a tunnel there, and if I give that tunnel a name, just call it O for the output here. So I connect the tunnel here, then that has got the value of O, okay, the tunnel. So if I want to make the connection from here to here, rather than actually drawing the wire down like this, I could just copy the tunnel, okay, and I can stick the tunnel and just put it on the wire like that, and that point there is now the same as that point there. It just saves us having to draw lots of wires around about, and you'll see that later on at the top level hierarchies of the CPU. Also have the clock here as the main clock. So again, you can set up the tick and enable tick, high duration, low duration. I've just left that at 1 to 1, and you can go through the simulation. If I put simulate and I put in tick enable, that's the clock running through and it's just ticking away. I can stop that tick. I can also tick it myself just by simply touching it one, up, down, okay, and that just gives you a simple clock. I think I can show you here if I've got my other tool to draw it here. So it just gives a a simple equally spaced high and lows. Okay. Okay, so this is the same as that, is the same as this, is the same as that. Okay. Let's see what else. Just a couple other odds and ends that we might find useful. Logism, that's it. Again, you can put a constant in for power, so I can tie a point high. Well, I can't tie that point high. Well, I can actually. You see, it's gone. It says incompatible with, so you can actually put an 8-bit because an 8-bit input, and it's tied it. Okay, so you can tie it. You can tie it high. You can tie stuff a point low to the ground. We're not interested in this here at the moment. And these are the basic gates that I'm going to be using. Okay, and as much as I can, I was originally thinking about just doing it all in NAND gates. Okay, so I would build up an AND gate using a NAND gate, and I build up all the other basic gates using NAND gates. But I decided against that simply because it's whenever I went to draw up the hierarchy, it just wouldn't look as neat and tidy as these here. Okay, so I'll allow myself to use this lot here. So I'll build the CPU up pretty much with the NOT, with a buffer and or NAND, NOR exclusive OR, and this control buffer as well, control buffer and control inverter. So those are the only really gates that I use, okay, throughout the whole of the design. There are other things in here, multiplexers, but we're going to build all those up, and encoders and selectors. We'll build those up ourselves, okay, using the basic gates. And there's these arithmetic units, but again, we're not going to use them. We'll build everything up from scratch. And the memory as well, we'll build the memory up from scratch as well. But in order to load the memory from an external source, in effect, we will use this this RAM here. Okay, and let's see what else we have. We'll be using a button as well, and the hex displays, we'll use that, and that's pretty much it. So that's everything we really need to know about Logism. And so the next video we'll get started and we'll look at the simple NAND gate and see how we can be used to build up all the rest of the other gates. Okay, thank you for listening, and goodbye.